for the safety of yourself, your families, your colleagues, and the world at large, we are very sure that all of us are observing the precautions, the safe distance, wearing a mask, and all other advisories which are issued by the government authorities and the medical authorities. But again, starting on a very optimist note, we have to manage the coming winters, and come spring season, hopefully we should have the brightness, usual brightness, with the vaccine in our hand. Like always, I will take a minute to introduce or reintroduce the Tunneling Association of India, an organization which works under the aegis of Central Board of Irrigation and Power. It was formed in the year 1976, and since then it has been a part of the highest body in the world for setting the standards and the practices in the world of underground space. Now, the mandate of the TAI is basically to provide a platform for all those who are connected with the underground space, that is, the students, the teachers, the research community, the designers, consultants, constructors, builders, material providers, machine providers, and everyone. We exchange information, we set certain technical papers, publish certain magazines. We are also the official representatives of our country at the ITA, including the WTC. We are the official nominated agency to hold the World Tunnel Congress as and when it is allotted to India. We do once in 2 years, we do a program called the Tunneling Asia, where we also do another mini program called the Tunneling Asia Awards. We are primarily concerned with the safety of the tunneling world. And another new chapter, which is got added, relatively new, it's not so new, is the young members of the TAI, which was added in the month of December 2018. That is our young tunnelers who are less than 35 years of age. That's the brief introduction of TAI and its own activities. We have another sister organization called Center for Excellence for Tunnels at National Highway Infrastructure Development Corporation Limited, in short NHIDCL, as a platform for advancement of tunnel development works in India. There again, the aim is that they are mandated to provide the thought leadership, the strategic advice, and problem solving inputs to those who are practicing tunnel. Similar kind of mandate as us, and we have decided the two of us will work in a very collaborative manner. Now, that was a brief introduction. Ladies and gentlemen, I'm very happy to introduce to you our new Secretary General of the TAI, who's the Secretary of CBIP, Central Board of Irrigation and Power, Mr. A.K. Dinkar. Yeah.
Thank you.
He's already on the screen. Now, Mr. Dinkar has very recently joined, I would say precisely 15 days back. Before joining this organization, he was the engineer-in-chief and head of the Department of Irrigation Department of State of Uttarakhand. He's a highly qualified person. In addition to his degree in civil engineering from the Punjab Engineering College, he's done his master's from IIT Roorkee and also an MBA from the Sikkim Manipal University. His primarily the focus area and the area of expertise has been the water resources sector. Tremendous amount of experience in that, be it the infrastructure, managing, monitoring, flood management, and all that, groundwater management, all that is associated with the water resources. And what I found was very different departure is that being a waterman, he's also had an exposure to the road building person. He's had a stint as a chief engineer of a program, flagship program of the PMO, which is called the Pradhan Mantri Grameen Sadak Yojana, PMSGY. He was the chief engineer and the deputy chief executive officer, again located for the state of Uttarakhand, located in Dehradun. He is rather the chairperson of the Institution of Engineers of Uttarakhand State, and has published innumerable number of research papers. So I don't think we could have got a better qualified and experienced person to lead this organization called the CBIP. Having introduced and ex officio, he's also going to be the Secretary General of the Tunneling Association of India. Welcome on board, Mr. Dinkar.
Thank you. Thank you.
Yeah, and we hope you have a wonderful innings, and we hope with your arrival here, the TAI will get a further boost to its activities. Now, coming to the speaker of the day, Dr. Harald Wagner. Now, I would like to Dr. Wagner to share his video now. We want to see him. And as I introduce him.
Well, I have to ask Mr. Utan to show my picture on the screen because I don't have it on the screen. All I have on the screen is my presentation.
Oh, great. Then your voice is great. So you almost understand that. I think maybe previous time you've had a look at his, because we were now he spoke to us about a month back, and the subject of discussion then was tunnel construction concepts. And today he's speaking to us on a slightly different subject. Now, ladies and gentlemen, I'm going to introduce him again for some of you who may not have really remembered that what an accomplished person Dr. Wagner has been, or is rather. I think one of the best known people in the industry, in the tunneling industry. He is a PhD, he holds a degree of PhD. He's a licensed master builder, and he's a government counselor appointed by the President of Austria. He's been working with the World Bank, or he has worked with the World Bank as a consultant for more than 15 years, is an international expert in the field of underground space with an overall experience of more than 40 years in the design and in the construction. He's been a vice president of the International Tunneling Association, vice president of ITA, and he's also been an expert member on working group of the ITA. That's not all. I can continue. He's worked in more than 35 countries. So he is, I think, one of the most well-recognized people in the industry field. He's been teaching also. He's been an assistant professor at the University of Graz, which is probably worldwide known as one of the best universities in the world as far as the tunneling is concerned. Now, subject of the day that he's chosen to educate us is the tunnel maintenance and repair. Let me share it with you. This is an area where probably we don't concentrate too much. We concentrate on the design, the construction, and the inauguration, and we very conveniently tend to forget the M&O part of it. Tunnel operation is not easy. We all know that in a life cycle concept, all these structures, especially the underground structures, would also need maintenance and repair periodically, both minor, routine, and major preventive maintenance. To do that, you have to get into that space again. So once again, when you get into the underground space to do certain repairs, especially where certain damages have happened, you are again moving into an uncharted territory. The risk to human life and property always remains. So you have to be very cautious, very careful, and it has to be done in a very organized and in a very planned scientific manner. What is more important is that, especially during the construction stage, once the building is made, all that you have is the as-built drawings, the documentation. At times we find that some of the firms, some of the clients are poor at documentation. Now, this is the importance of documentation, that tomorrow, when you have to open up one particular part of the tunnel, a sub part of a system, you only can rely on those documents. He's also going to speak to us the importance of documentation, correct kind of documentation. So I'm not going to be now anymore between you and the speaker. Over to you, Dr. Wagner. Welcome on board once again. Pleasure to have you with us. Over to you.
Sir, hello, just a minute, Sharma sir.
Ji.
Sir, our Secretary General may like to say a few words.
Yeah, please. Okay, I should have invited him. So, Mr. Dinkar, my apologies for not this thing. So before we hand over to the guest speaker, may I request you to say a few words to the audience?
Thank you, Mr. Sharma. Good afternoon, all. I express my sincere gratitude to all for participating in today's virtual training session on tunnel maintenance and repair, organized jointly by Tunneling Association of India (TAI) and Center of Excellence for Tunnel Studies (CETS). In the present COVID-19 situation, skill enhancement and training of professionals is a challenge. TAI plan to organize virtual trainings workshops to disseminate the information about the latest techniques, new trends and experiences gained by the professionals. I am sure it will enhance the knowledge of tunnel and underground young professionals in the country who are developing their career in this field. We have already conducted 8 virtual training programs on the different topics on tunnel and underground space development. Today's is the 9th program in the series. We have planned another 30 more programs on such topics. So total will be around 39. Today's program on the topic of tunnel and maintenance is a very important and apt topic and will be conducted by renowned international tunneling and underground space associations ITA speaker Dr. Harald Wagner. It is the 3rd program being conducted by Dr. Harald Wagner. I am very thankful to Dr. Wagner for sparing his valuable time for conducting today's program. I am sure all the participants will be benefited from his vast knowledge shared during this program. We also wish his participation in future programs as well. Thank you. Thank you very much.
Thank you, Mr. Dinkar. Over to you, Professor. Dr. Wagner, all yours.
Yes. Okay. Thank you very much for this very comprehensive and very, very competent introduction, both by His Excellency the General and also by the new Secretary and Mr. Dinkar. Thank you very much. I'm very much impressed about your competent and comprehensive introduction. So we are talking today, as just mentioned before, about tunnel maintenance and repair, which is kind of an issue which is sometimes like a unwanted child of tunneling. But it is, in fact, very, very important. And though when we start as young engineers, our professional career in the field of tunneling, we start with design and we start with construction, and very seldom that we start with maintenance and repair. And that also is reflected in my career, which I'm going now to spread out a little bit to all of you, and where I hope that I can gain your interest on this subject. So let me just introduce not anymore myself, because my biosketch also will be in the printout if you prepare, if you send out the printouts from the presentation. So that would be just repeating that. But what we really have, what we are faced is that, you know, when we have 40, 50 years ago, we bought a car and we didn't look too much about the maintenance of the car. And there was some very few companies at that time which have had the far side to understand that maintenance for a car is important, because a car is aging. But the same is also for tunnels. Also tunnels age, and tunnels get sick, and tunnels get affected by the geomechanic conditions, by the loads, and also by the materials which we have to transport in the tunnel. So tunnels get sick. So in order to control the sickness, we have to maintain the tunnels. And on this picture, you can see that that is what we do. That is what we do in an old sewer tunnel. For instance, in the picture here, we are providing maintenance by checking what is on the side walls, what is in the roof of the tunnel, what is in the invert of the tunnel, and we have to go into that tunnel and to check it. And to check it was originally only by going into the tunnel. Nowadays we are using robotics and we are using even drones for the maintenance of the tunnel. Now, what I want to also tell you is that reflected in the table of content which you see here is my personal experience with maintenance and operation of tunnels. And I'm in particular blessed to can show you the Mont Blanc tunnel and the Tavan tunnel, Mont Blanc tunnel between France and Italy, the Tavan tunnel in Austria itself. And I will also show you some Indian projects, in particular the Rampur tunnel, which is a hydro tunnel. And Mr. Tinker also has been introduced now as the expert in hydrotunneling. So there will be some information about that also on hydrotunneling. But I will also focus on monitoring and programming, but I will also focus on what we need to do for the maintenance of the ground, because the ground is the surrounding subject around the tunnel. I will also let you know some of the ITA recommendations and some of the recommendations which are further on from the International Tunneling Association recommendations. And then I will also talk a little bit about the facility, about the tunnel facility itself, about the details and the construction of the tunnel facility and the maintenance, and then finally come to some conclusions. Now, let me go to the preamble as an part of the introduction. The year 1999 has been a very special year, both in the professional world of tunneling and also in my personal life, because in February of 1999, there happened a big accident in the Mont Blanc tunnel between Italy and France, with roughly 50 people which have been killed in the fire at that fire accident. And after that fire accident, of course, in the world of tunneling, we have had the question, we have been faced with the question, can that happen in an Alpine crossing tunnel, in a long tunnel in Austria, also more than 10 kilometer long highway tunnel. And 3 months later, we got the answer, because in the Tavan tunnel, which has been the longest highway tunnel and one of the very early base tunnels in Austria, a fire happened in May. And I remember that I have been in a marathon run in Vienna in June, and then they called me just when I finished the running. They called me, are you available for a television conference and talk in the Austrian broadcasting television company? I said yes, okay, and as tired as I was, but I had to go there. And I remember very clearly about the questions from the journalists and how that could happen, because just the Mont Blanc tunnel fire happened. But that was not yet the end of the year 1999, because on the 23rd of December of the same year, 1999, my private residence also burned completely down. So I did spend the 24th, which is a special day in an Austrian country, 24th of December, I had to go to find some roof above my head and the head of my family at that time, because the house was completely turned down, and there had been some tragic moments also, because 3 fire department came to the house to save the house, but they couldn't save it completely. So one fire department guy also got killed in that on that same day, in the night actually. Now, what it says is that maintenance and repair and modifications of underground structures are always a challenging task, because every of this structure is different and has to be reconsidered. And we are now trying during today's virtual conference to better understand and to better prepare ourselves also for such unwanted and unexpected conditions. In many different aspects also, we have a lack of reliable information and documentation and records, and that also is multiplying the problem, because lacking of both of design and construction of structures, of subsequent modifications and possibilities for quick repair, quick and profound repair. So just to go back to the Mont Blanc fire, it has been considerably unforeseen from the point of view of expense and also from the point of view of rehabilitation during the repair operation. So let's go to the next slide. The next slide is a slide which shows tunnel maintenance and repair, in particular the workflow. Now, there are two basic types of workflow. One is the preventive maintenance, and the other one is the corrective maintenance. And from the point of view of preventive maintenance, there is maintenance on a periodic-based maintenance, and then on a calendar-based or operation and time-based maintenance, resulting in respective checks and services and adjustments, and also in the evaluation of the system conditions. While the condition-based maintenance results in inspection and in measurement, in actual measurement of the condition of the structural lining, and also in the recommendations for the adjustment and overhauling, and eventually for the repair and for the replacement. Where from the corrective maintenance, first of all, we are looking to search for the errors, and for the errors on a component level, means on the structure level, on the dewatering level, on the different types of components. And then the decision has to be made whether it is possible to postpone or whether it is necessary to make an immediate repair, followed by an overhauling and evaluation of the entire system. Now, the International Tunneling Association has been working within the working group number 6. So maybe we have already understood from previous virtual conferences that there are different types. Now we have about 16 or 18 active working groups in International Tunneling Association. Working group number 6 has been a working group which mainly focuses on maintenance and repairs. And there have been a number of very interesting publications from this working group on maintenance and repair. And these publications are listed here. They are free, have a free access from the internet. If you click to ITA, ITA-ITES, on the internet. You can click on publications and then you will find these particular 6 publications which are related to maintenance and repair. In 2017, there is a publication on structural fire protection for road tunnels, which go back to the Mont Blanc fire in 1999 and to the Tower Tunnel fire, but there have been other fires later also. And I cannot cover all of the possibilities or all of the accidents which happen, but a major number of accidents with regard to fire also happened in metro construction and in metro maintenance, underground subways. In 2004, there was a guideline issued for the structural fire resistance from road tunnels, which also is a predecessor from the structural fire protection 2017. In 2001, there was a study published on methods for repair of tunnel linings, different tunnel linings. I'll show you later the 2 examples. Basically, these examples relate to either mechanized tunneling, means TBM tunneling, tunnel boring machine tunneling, and to conventional tunneling, which is also known as New Austrian tunneling method, but has a different other names also, like sequential excavation and so on. In 1995, there is a paper, a report published on non-destructive testing methods for assessing the state of tunnel lining for the structural, from the structural point of view. In 1991, there was a published paper on damaging effects on water tunnels during working life, which is a little bit different because of accessibility, because if you have a water tunnel, like a headrace tunnel in a hydropower project, access is very, very limited. And in 1987, one of the early reports on civil engineering records of underground structures. So a lot of underground structures are documented in that report of 1987. Now, I would like to talk a little bit about the history of the Mont Blanc road tunnel, just to give you an understanding of how such a tunnel develops until it is faced with a situation where a new concept has to be developed. In 1957, there have been 2 companies. Why 2 companies? One was Italian, the other one was French, which created, which have been created for the construction and subsequent management, including maintenance and repair of these tunnels. In 1965, means 12 years later, the tunnel has been officially inaugurated and opened to traffic. In 1999, we have had this huge fire, this accident, and the tunnel has been closed for traffic at this stage. So following the next 3 years, the concession companies have been engaged in carrying out important restoration and modernization. So that was a complete new development of rehabilitation for the Mont Blanc tunnel. Then in 2002, means 3 years later, the tunnel has been reopened for traffic. And in 2004, the works are assimilated to the drawing up of the European Directive on minimum safety requirements for tunnels of the trans-European roads. So that was the political consequence that a new drawing up has been developed in 2004. And in 2006, a new convention has been signed between the French and the Italian government relating to the Mont Blanc Road Tunnel, going back to the 1953, a novel of the original, very, very original idea. This is a concession-based project, which is set according to this new convention to expire in 2050. That means 30 years from now. So these are the typical concession projects, and we have more and more concession projects in our infrastructure. Now, just to give you an idea where the Mont Blanc tunnel is located and why Mont Blanc means the White Mountain. And you can see here on the right side, the White Mountain above the tunnel entrance, above the portal. The tunnel actually is here in the middle of this sketch, and it is 87 kilometers from Geneva. Geneva is on the border between France and Switzerland, and between and 151 kilometers north of Turin, or 224 kilometers west of Milan. So that's where the tunnel is located. And let's have a look to the also restored and modernized tunnel. I would like to show you here an axonometric view of that restoration. You can see here that we have by traffic, it's in both directions, one tunnel. And you can see here some lay-bys, and you can see also some administration offices here. But what is more important also, you have every 500, approximately 500 meters, you have such stairs which goes down under the carriageway. And here you can see that under the carriageway, you have this kind of chambers in case that there is another accident, hopefully not happening, but just to be prepared for another accident. People can move down here, the stairs, and then they can escape safe. So there is, the risk still exists, but it is very, very much reduced. So let's go to the next project also, which is the Tauern Tunnel Highway in Austria, crossing in the north-south direction, as well as also the Mont Blanc Tunnel is in north-south direction in Europe, but the Tauern Tunnel is more to the east of Europe, actually in the middle of Austria. In May 1999, there was these heavy traffic accidents, and it was only 3 months after the disaster from the Mont Blanc tunnel. The fire damaged the tunnel. As a subsequent disaster, there have been less fatalities in the Tauern tunnel. It was 11 or 12 fatalities at that time in the Tauern tunnel. And what is very different from the Mont Blanc tunnel is that the tunnel was, first of all, closed, but in September of 1999, the repair has been finished just after 3 months, and the tunnel could be reopened. But this reopening of the tunnel was due to the strong pressure from the traffic, from the users. And the reopening of the tunnel was not without consequences. There have been consequences both from these two accidents from the Mont Blanc and from the Tauern tunnel. The consequence was, among others, to build a new tunnel, to build generally new tunnels which exceed the length of 1 kilometer, first of all, with concrete pavement instead of asphalt. So also the town highway authority has decided, together with the Austrian government, for the construction of second tubes. So the construction of the MONTBLANC tunnel has been, did stay with the binocular traffic, but in Austria, and that could not be done within 3 months. It has been done decades later, that the Austrians decided to make second tubes for this type of heavy frequented highway tunnels. And because the second tunnel tube can help to reduce the risk of services and help emergency services to tackle in the event that there is a fire in the second tube. So this is the basic difference from the point of view of maintenance between the two highway tunnels. Here I would like to show you just the second tube of the town tunnel on the right side. You can see we have a right-hand traffic in Austria. You can see the left and the right tube of this. And also you can see the construction of the second tube. So the second tube, though it's a very long tunnel, approximately 10 kilometers, has been using again the new Austrian tunneling method, even or the shotcrete method, you know. Even if the length of the tunnel was such great, but that was also one of the reasons why to study what is the progress between the construction in the 70s, or in the 1970s. The first tube has been constructed, and the second tube has been constructed at the beginning of the 21st century. And there have been significant improvements from the point of view of progress, construction progress, from the point of view of driving progress, from the point of view of deformations also. And so that it was kind of a study project, because one tube has already been done in the old-fashioned way, and the new tube has been done with advanced technology, and it actually has been very successful. So I just want to touch also one of the most famous and most successful projects in the world, which is the 57-kilometer long Gotthard base tunnel under the Swiss Alps. The Gotthard base tunnel is a 10 billion tunnel under the Swiss Alps for railways, and this Gotthard base tunnel has been 60% or 70%, something between 60 and 70% has been done using tunnel boring machines. And the difference has been done with the conventional drill and blast technique, with special techniques for the control of the deformations, because there is more than 2,000 meters of overburden in the Swiss Alps. And this tunnel, which has been opened in 2016, has left us with the impression that for the real underground problems due to mountains, due to length of extension of tunnels and so on, can only be done if we use the underground, if we make significant use of the underground. And the Swiss Gotthard base tunnel has been such a successful project. I'd like to give you a few salient features for the Gotthard base tunnel. It has been, as mentioned, already in 2016 completed. There has been almost 30 million tons or 80 million cubic meters of excavation, which corresponds with the equivalent of 5 pyramids from Gizeh in Egypt near to Cairo. There have been 4 tunnel boring machines used. The daily excavation was between 25 and 30 meters in optimum rock condition. The trains which are traveling now under the Swiss Alps are at a speed of 250 kilometers per hour. The speed can be used because we have 2 main tunnels, 2 parallel tunnels, and the Gotthard base tunnel and the Sceneri base tunnel, they are complementary each other. They are both on the north-south route from Europe, from the north of Europe to the south of Europe. So these 2 tunnels are very similar in the aspect of high-speed train. The Gotthard base tunnel is 151 or let's say 76 kilometers for each tube, including Sceneri and Gotthard base tunnel. The composed western tunnel is 57 kilometers, and the eastern tunnel is about the difference, which is something, there is something wrong, excuse me. It is not again 35 miles. It is okay. It is true, but it is for both of these western tube and for the eastern tunnel. It is, each of them is about 57 kilometers. The tunnels allow for 200 to 250 trains per day to pass under the Alps. So sorry for that, but to be clear and finally to confirm, 57 kilometers each tube of the Gotthard base tunnel. So we are coming to the point where we have to talk about the railway tunnel and maintenance of such a railway infrastructure. The lining structure is installed. After the lining structure is installed, electrical and mechanical and electromechanical systems are going to be installed. These installations are followed by the installation of infrastructure for ventilation, for water supply, for drainage, for air conditioning. So from the point of view of maintenance, we have to take all this into consideration. We are not only stuck with the structural condition, we are also faced with the other infrastructure installation. Then we have included temporary and permanent auxiliary structures like buildings for the maintenance, for the control buildings, like cranes, doors. We have special doors, usually in highway tunnels. We have fire protection doors. We have to look into the floors. We have metal structures and other fire protection technology. The Gotthard base tunnel actually houses 2 tunnels, 57 kilometers each, but also has 176 cross galleries and 46 other galleries which are not crossing. The Sceneri base tunnel is housing a variety of equipment, including railway infrastructure, ventilation, evacuation, and fire protection doors. There are 2 multifunctional stations in each tunnel, allowing the trains to cross over. If there is a problem in one tunnel, then this can be done crossover. We also, let me mention this, that's the same. We have also on the Channel Tunnel between England and France, Dover and Calais. We also have this crossover option for the trains. The tunnels include emergency stop stations, climate control systems to ensure always fresh air in base tunnels and to ensure also consistent temperature in the tunnel. Now, what we also have to do when we are planners and designers, we have to think about a hypothetical mishap if there is an accident. In the preparation, in the design stage, we make a simulation of train fire ventilation system response, which should be largely automated and should allow for quick control. There are a number of uncertainties and unknowns in our underground infrastructures when we look from the point of view of maintenance. When we have a lack of information, for instance, because of unknown working shafts, if we have abnormalities from the point of view of geology and unrecorded variations in structural elements, that can cause such mishaps. Accidents can occur as a result of ignorance. So this is a very heavy argument. There should not be any ignorance in any of such important underground infrastructure projects. But we have to look into the risk of such ignorance and the assumptions from the point of view of the assumptions made during functional and structural design of the underground facilities. Difficulties may also be encountered during construction, and they can cause ongoing problems during the life and operation and maintenance of such structures. And the best example here is the Tower Tunnel accident from May 1999. Now let's talk a little bit about hydro tunnels, and I did pick, because of my personal experience also, I did pick the Rampur project in Satluj Basin in northern India. Here you can see the yellow path is the headrace tunnel. It's about 15 kilometers from the intake to the powerhouse here. This is a tunnel which has been using drill and blast operation in the late 1990s and early 2000 until it became finished. So some of the salient fissures from the Rampur hydroelectric power projects where the maintenance is completely done by the owner, which is SJVNL Satluj joint venture. The project is a 412 megawatt hydropower project with about 15 kilometers of tunnels in Himachal Pradesh. The environment is defined by the type of the project, which is a run-of river project, and it was granted environment clearance by the Ministry of Environment, Forest and Climate Change in 2004. The venture Rampur is a hydroelectric power as a public sector venture being executed under the aegis of Satluj Jal Vidyut Nigam Limited, SJVNL in short. The company has under execution 10 more hydropower projects and aims to tap 6,000 megawatts by 2022, which is very soon. The cascade is designed as a cascade runoff river plant, which will not draw water from the river, but from the tail race of Naphtha Chakri project or NP project. Naphtha Chakri project is also owned and maintained by SJVNL, being one of several megadam projects in Himachal Pradesh. So there are some damaging hazards to an underground structure facility, whereas we have to think about the resistance of structural concrete elements like walls, ceilings, partition walls, cast-in-place concrete, shotcrete, and so on, which will decrease once the concrete surface temperature reaches 380 degrees. So that's a threshold value from the point of view of the concrete surface. For structural steel, this threshold is set up higher, but still 550 centigrade. Concrete or steel elements will be damaged with visible cracks after a fire leading to temperatures above these thresholds, but also invisible ones. We cannot see what is outside, or because only we see in the tunnel when it's finished, we only see what's affected inside of the tunnel lining, because it's outside and that's an inaccessible location generally. Repair works will be necessary to replace the damaged elements, concrete elements or damaged structures or stretches, and recover the original mechanical performance. When concrete is affected by heat, it spalls. This phenomenon is dependent to many parameters and very difficult to estimate in common practice. So that is why programs have been developed, supported by the European Union, for the use of steel fibers or fibers in general as a reinforcement for concrete, in particular in the case of fire. Now here I would like to show you one crack, typical precast concrete tunnel lining crack from TBM-driven tunnels, which is allocated also on this circular joint. So concrete segments is one type of structural element. The other type is cast-in-place concrete. Let us just quickly talk about the global context of hydroelectric power and hydroelectric power tunnels. Hydropower tunnels remain the world's primary and most important source of renewable energy. And why is that? I figure out that this is because of low cost for maintenance. If you compare with other structures, maintenance is generally multiple times of the maintenance cost from renewable projects from hydropower. Hydropower amounted in 2012, a little bit old figure, but in 2012, 3,600 billion kilowatt hours of worldwide hydropower. It represented over 16% of total energy production, which has been for sure changed because other renewable energy sources became more attractive, in particular solar and wind. And this is with reference to the International Energy Agency, IEA, and US Energy Information Administration, or EIA. What we really are very concerned about maintenance and repair risk, which is substantially reduced when we have good records from our underground facilities. In order to make use of these good records and in order to monitor the development of various parts of the facility, we need to do monitoring, but also we need to do preventive maintenance and repair programming. As I mentioned before, in these two parts. It will reduce the cost of supplementary investigation before carrying out additional works. So this is very, very important because the more information is available when we start with maintenance and operation and repair, the more cost effective it can be done. This picture shows you one of the London Metro Crossrail tunnels, and what is very new here, nowadays we are using drones not only in political conflict and war, but also for civil use of civil structure and supporting monitoring and control of tunnels with such drones. It's a three-dimensional mapping using these drones, which gives us a lot of help in the future, and it may even be used in hydro tunnels if they are not completely filled. Let us talk very briefly also about the role of the underground, because the underground, the ground itself, whether it's rock or soil or mixed, is forming a geomechanical load and being part of the lining resulting from the excavation of the tunnel. So we have in all types of underground construction concepts mentioned in the previous virtual lectures, we have the same view of the underground. It is part of the support as well as it is a load. The ground is to be turned into a material providing stabilization support to the just excavated underground facility or cavity. So the ground is turned from a load to a load-bearing structures. In other words, structural understanding to be achieved in design, construction, and also in recording. And the engineering model to be developed in an unaccountable number of different geomechanic ground conditions. So I always used to say that there is not even a single tunnel in our world twice the same. Every tunnel is a unique structure. Every tunnel is different from others, though we can learn from experience from other tunnels. So the structural understanding is very important, and in particular when we come to conditions like MONTBLANC tunnel or Tauern tunnel, you know you have the fire, so you ask yourself, what is happening outside of the lining? How much is the rock affected? And that is something which is also important to understand, both from the point of view of geology and also from the point of view, if we have water, then we have to look also what happens with the water. So ground robotics has been now used more and more, and there are about 10 years of experience in researching and testing when using ground robotics in tunnels of our infrastructure projects. Now I would like to come to the point of the International Tunneling Association recommendations for recording of documents for recording of documentation and data. We have 4 types of records to do. The first one is records should be compiled of the design of the construction, eventual alteration during construction, and the maintenance of underground facilities. But records also should include details of geologic conditions, both of the predicted conditions and of the actually encountered conditions. It also should include details of the services of the adjacent structures and so on. Then record documents should also be separated from copies of documents such as operation and maintenance manuals and so on, which are in daily use. So the meaning of that is it should be separated in order to be sure it is available when it is needed. Records should also include, as much as possible, informations listed in the subtopics of a facility. Further recordings are also recommended. In particular, the owner of the facility and the owner's engineers, they should recognize the need for records at the outset of planning and should make appropriate arrangements at each stage of the project. So the need for records has also always been given a high priority. Consideration also should be given to the storage at the facility of full-size documents showing layout and general details of the facility, showing ground and groundwater conditions and the like. The recommendation is also underlining to assemble as much as possible information listed in the subtopics so as to be available without delay, as to be available always immediately. The records also should be kept up to date by recording alteration and maintenance work in appropriate detail. That means that the maintenance has to be specially recorded in addition to all of the other data recording of the facility. Now, the layout of the tunnel should include, of course, all of the plans, all of the planning which has been done by the designer. Has to go into the details of the different sections of the facility, also into the details of the access arrangements. It also has to define the relationship to the surface features. That means if we drive a tunnel underneath a village, so that has to be also defined and has to be featured in the layout. Then we have also the legal documents on the possession and on the occupation of lands in the vicinity of the tunnel. So that is something which needs also to be documented sufficiently and always be available. In addition, also services have to be recorded, in particular regarding crossing and adjacent to the facility, but also as it is standard that as constructive drawings have to be recorded and have to include all dimensions and all of the structural details, including also the materials used and every special event which has been faced. Now, every facility also is using special specifications and standards. So these specifications should include the technical specification of the work, which is in the contract document, always available. But also it has to define the standards which have been used in the work and the current at the time of the construction. It has to include all of the conditions from the groundwater access and from eventual groundwater influence and groundwater data. Groundwater conditions in general should also include some chemical testing. Very important also site investigation records, in particular those from borehole logs, from testing, both on site and testing in the laboratory, and all the respective reports of these site investigations. There is a particular design philosophy in each of these underground facilities, and these design facilities has to talk about loading conditions, has to talk about safety factors, has to talk about also threshold values in monitoring the facilities. But of course, part of the specifications and standards are also calculations, both functional calculations and structural calculations, and their reference to the standards. Okay. Then we have also to think that if there are guidelines available, these guidelines for maintenance and repair have to be applied for any type of a tunnel facility. It has to be applied to providing consideration is made as to the usage of the tunnel and to the type of material that is transported in the tunnel, whether it's a traffic tunnel or whether it's a hydro tunnel, whether it's another cable tunnel or a sewer tunnel. So all of these has to be included and has to be related as much as possible to the guidelines if they are available. Construction, operation, and maintenance should also be documented from the point of view of the dates, of the most important dates of the construction. Of course, from the point of view of the name of the client and the owner, but also from the point of view of the engineer or engineers, and from the point of view of contractor or contractors, if there are sometimes we have a separation between civil contracts and electrical and mechanical contracts. So that all has to be included. The engineering report of the facility shall include methods which have been used in the construction and in the preview of the maintenance and operation. The sequence and timing of operations, which is recommended to be stated, and the problems encountered and their solutions for the problems. It also has to include the technical site records, means the records of the construction contractor and the records of the construction supervision engineers and so on. So it has to include also all temporary work details. It has to include if there are shafts, access shafts, if there is piling has been done. It has to include every aspect which has been used from the point of view of strengthening the underground with anchor bolts and so on. But it should also include historical records, papers from publications from other comparable projects, other publications, and so on. The records have to include the operating manual. It should include recommendations for the inspection and for the maintenance, and the results of such inspections, means the reports of the inspections. It should also include records of long-term monitoring. So this monitoring is the absolutely safeguard for the safety of the facility. It has to record also maintenance activities, including investigations, location, date, and nature of the work. Records also have to include if there have been modifications, if there have been modifications from the point of view of investigations, from the point of view of drawings, from the point of view of calculations, as for the original work. So all of these modifications also have to be part of the recording work. And other incidents that could affect the life of the facility, no special incidents that I would mean in that can, just general, all incidents have to be recorded. So again, we come back to the introduction of the lecture today. What are the maintenance strategies? And the maintenance strategies basically have different types of maintenance that were introduced. In particular, what kind of type of maintenance before the maintenance really starts, then what of preventive maintenance during operation, and what kind of corrective maintenance can be called in the maintenance strategy of the project. When we come to the preventive maintenance, then we have to look into preventive actions, which are generally referred to those actions that are applied in the structure regularly and that try to maintain the structure from unexpected failures and keep it working. So preventive maintenance is a very, very high priority in the maintenance strategy. Preventive maintenance also refers to the degradation process. Steel can corrode, concrete can spall, and so on. Yet it extends the time needed for corrective actions, and operational capacity will be increased. So that has a very, very cost-effective influence on the life cycle cost of the project. Preventive maintenance also are measures that are performed in a timely manner and based on a routine, therefore less large-scale repairs will be required. So again, this preventive maintenance is cost saving, is a cost saving of the operation of the underground facility, and from that point of view has a high priority in planning. A preventive maintenance schedule may include also cleaning of the structure, may include also lubrication of the structure, may include oil changes, may include other adjustments, for instance, in the control of the facility, but also may include some routine repairs under the title of preventive maintenance. Now we come to the next strategy, which is corrective maintenance. What is corrective maintenance? Corrective maintenance is another strategy which will be applied on a structure when a flaw is detected. So there is already some problem. And if this problem occurs, then we have to go to the corrective maintenance. Corrective maintenance purpose is to restore the operational capacity of the structure to an acceptable level. Acceptable level we also have in other risk management terms, acceptance or non-acceptance. Acceptance may be also related to cost. So the purpose is to restore the operational capacity when a flaw already has happened. And that has to be restored in order to get the facility work again. Corrective action can be applied immediately or deferred to a certain time depending on the importance of the flaw. That means that sometimes this action can wait a little bit, not too much, but if we can decide that it can wait for another days or weeks or whatever time frame is suitable, then it may be less expensive. So corrective maintenance includes also different types of actions, and the application of each depends on the deferred, on the flawed or defect situation. So we have to make a definition of what type of action we have to take in order to solve the problem. It may also include the replacement of a component of the structure when it is the final solution in a worst case scenario. So the worst case scenario is that the facility cannot be used anymore, and that means we are losing revenues or we have some other difficulty in diverting traffic if the tunnel is closed from the point of view of a highway tunnel, and so on. So it can have very significant influences and need to be considered in advance. So as a summary of the virtual lecture, I would like to also give you some recommendations. And such recommendations are provided to ensure, for instance, fire-resistant tunnels, to ensure a global safety level has been reached, and to reduce non-operational times and economic losses to prevent catastrophic collapses of structures. So this all is included in the recommendations for the global safety of the structure. We also have to look into those guidelines which are developed by an extensive review of codes, of existing codes. Every country may have different codes depending on the climate of the very country, depending on the mentality or the other culture of the country. So these codes have to be reviewed. They have to be reviewed in regards to maybe existing regulations, ordinances, and also maybe to existing case studies and published research works. The guidelines are intended to provide criteria for the protection of existing as well as new tunnels in design and construction and in maintenance and in operation. So that would be the summary of this presentation, and I would like to come to the very last slide, where I would like to salute the audience of this virtual lecture cordially is saluted. And I would also express an invitation to come back and to bring your friends. This last slide also shows maintenance of a tunnel wall structure from the point of view of evaluating the structural stability. You can see in this slide of the highway tunnel in Austria. So for now, I would like to also come to a conclusion and thank you very much for your attention. I really appreciated it, and I hope that you have a lot of questions. If you have questions, we can either talk about, because we still have some time left, we can talk about following this virtual lecture, or you can write it down. You can write down your questions and send me an email, and I will respond to your questions via email. Thank you.
Thank you, Dr. Gerhard Wagner. I would like to request all the participants, if anyone would like to have any question, query, they can ask now, or they can either send their questions or queries over the message or the mail or later on as well.
Sure.
It seems no one would like to have any, they don't have any questions right now. I guess we can finish it up. Thank you so much, sir, for sparing your valuable time for conducting today's session on maintenance and repair. And I'm sure all the participants will be benefited from your vast knowledge shared during the program. Thank you all. Thank you all the participants, and thank you to the speaker once again. Thank you so much.
Thank you also for your attention. I appreciate it a lot to be with you, and I hope that we will continue.
Due to his commitment to CBAP and appointing.
Hello, you had a question? I did hear some voice in the background.
No, I don't think so.
Hello?
Yes, sir.
If there is no question.
Yes, I don't think the participant would like to have any questions queried right now. So
okay.
We can
sorry to interrupt you, ma'am. There is one question in the chat box by Mr. Shrikant Reddy.
Okay. So can you please read the questions on his behalf?
Hello.
Okay, sir. There is one question from Shrikant Reddy, sir. How will AI will help in maintain and repair of tunnels?
Can you please repeat your question? I did not understand. I just understood repair of tunnels.
How will AI, artificial intelligence, will help in maintenance and repair of tunnels?
Well, I think basically by using modern equipment, which I did show, for instance, with the observation of the drones, using the drones in a tunnel will be very helpful. I think on the other hand, there are special equipment also for artificial intelligence evaluation, and I think that this is the beginning of a new era of use of artificial intelligence in tunneling. So we will have a lot of new experience and sharing experience in the next couple months or years, and it will be very interesting. So right now, I think we don't have a lot of other experience than what I have shown in the presentation, in particular in the presentation of the Crossrail tunnel in London.
Any other question, Uttam?
No, ma'am.
Thank you, sir.
Okay.
Thank you. Thank you to all the participants.
I've been clicking on yes. I appreciate very much, and I would like to thank both His Excellency the General, and also I would like to thank to the new chairman of CBIP, Central Board for Irrigation and Power, for his very kind introduction and comments. Thank you very much.
Thank you. Thank you, sir. Thank you, all the participants. Thank you.
Thank you very much.